Hello everyone, welcome to the next lecture on the PY question series. In this lecture, I will explain you how you can solve UMVUE PY question series. Also, we will cover the complete and the sufficient estimator. Myself, Dr. Harish, you can simply follow my YouTube channel where you can find the playlist, and here you can search about the IIT JAM solution, and you can see this is the previous lecture which I have uploaded, and this is the base of this today's lecture. So you must watch this lecture in order to understand this lecture completely. Apart from them, there are many other lectures related to the IIT JAM mathematics and the statistics. Apart from them, there is one more playlist is named as GATE statistics, and you can see the various PY questions related to the GATE and the CSR net examinations in this playlist. So what is the objective is we will cover how you can solve the unbiased minimum variance estimators problems. So any of the unbiased estimate, firstly I will explain you the simple shortcut tricks so that you can solve each questions with the help of the 10 to 15 second time period. So keep watching till the last question of the video so that you can learn many shortcut tricks in this lecture. So any of the estimator, first of all, it must be the unbiased estimator of this is said to be unbiased UMVUE if this property is satisfied. So if I called this delta is my unbiased estimator and delta is said to be this, then you have to find the variance and it should be minimum among the others. But you can see this value is given to you, but how you can find the all other unbiased estimator? It is not an easy target for you. So then instead of applying this definition, I always apply this Lehmann-Scheffe Theorem. What is this theorem suggested to you? In order to prove that any of the estimator is said to be the UMVUE, I need to prove firstly it's a complete, then we have to prove the sufficient, and the third thing we have to prove the unbiasedness. So I have to prove these three things in order to prove whether any of the estimator is UMVUE or not. Now the question arises is what are the various shortcut tricks so that you can easily find whether it's a complete, whether it's a sufficient or unbiased. So I will tell you the shortcut tricks. So firstly, how you can check about the sufficient estimator. So before that you must know what is the exponential family. Any of the PDF functions is, if any of the PDF function is written in the form of exponential of the function theta into function of the x, like of this, a theta and the function of the x, then we call as the exponential family. Whatever the coefficients are there, this is simply a proportional to this. One function is the x or the theta. In other words, you can see this is the exponential, this is the x and theta function appear. So this is the exponential family. Again, if I written here, again you can see these are the exponential family. So your first target is to identify whether your given PDF is of exponential family or not. Then once you identify that this is of the exponential family, then we are easily able to understand what is the complete and the sufficient. For example, how you can check about the sufficient, how you can check about the complete. Firstly, I can explain about here, and then how you can check about whether it's an unbiased estimator. For that, as I recommended you, you can watch my previous lecture of the unbiased estimator. Now, if the given PDF or the PMF of the distribution is given in this form, then whatever the hx, that is the coefficient of the theta, is called as the sufficient estimate. The summation of the hx is the sufficient estimate. That's a very simple shortcut tricks I have given to you. For example, if I say my PDF is like of this is the exponential distribution, fine, is a x and theta. So then clearly say this is the exponential function. So what is my hx? Hx is the function of the x only here. So I can say summation of x is my sufficient estimate. How you can prove is a complete? So any of the statistics t, that is this statistics t, is said to be the complete if you start from the expected value of the any function, like if t is my here, then what is my g of t? It is a function of this hx. If it is 0, then g must be 0. So g is always unknown and your target is to identify g. If this condition satisfied, then you can say it's a complete statistics. But again, it is not an easy target for you. You can check about this condition. So what is the shortcut tricks is, if you can find an open interval, like if I say theta is greater than 0, so whenever the range is given to you, then it is a complete statistics. For example, here, so what is the UMVB? Uniformly minimum variance unbiased. So firstly, if you watch my last lecture of the unbiased estimator, I already gave you the tips. Whenever x follows my a comma b, fine, then x of 1, that is a lower, is my consistent estimator of a, lower limit. X of n is the consistent estimator of the upper limit b. Also, I have given you xn is my sufficient estimator of the upper limit b. Now I can use this. What is given to you? X follows my uniform distribution of 0 comma theta. What does it mean? X of n will follows, x of n is the sufficient estimator of theta. Fine. Now I have proved the sufficient. Now how you can prove the complete? So clearly say it's a uniform distribution. So x, this is my range. So clearly say I got theta is my greater than 0. So whenever you have a theta is greater than 0, or theta is greater than 1, or theta is greater than of any constant, then it is always complete. So now you have proved that sufficient as well as complete. Now the only thing which is you have to left is unbiased. So what is the meaning of the unbiased? I can check about here. Another shortcut tips for you. Whenever x follows my uniform distribution of 0 comma 1, then x of n will follows beta distribution of n comma 1, while x of 1 will follows the beta distribution of 1 comma n. Now if you look about that, this follows my here. So I can return x over theta will follows uniform distribution of 0 comma 1. So what does it mean? X n over theta will follows my beta distribution of n comma 1. So what does it mean? X n will follows theta times beta distribution of n comma 1. Then I can found the expected value of this. So what is that? Theta is outside. So what is the mean of the beta distribution? That is a over a plus b. Now clearly say, now my target is to make them as a theta. How you can make? If I divide it here, you can see this is my theta and this is my target. So what is the right answer is? A is my right answer. Always remember how you can prove the sufficient estimator. If you know the some tips, then you can do, otherwise I will explain you. Like here, you can clearly say this is exponential form. So what is my hx? Hx is coefficient of the theta. So you can ignore the negative sign, there is no issue here. So then your target is to find the sufficient estimator. So what is the sufficient estimator? H of x. So what is that? It's a k times x. So how many sides are there? 3 sides. So it's a I varies from 1 to n I, or k varies from 1 to I. So if I substitute here, it will be x1, 2x2 plus 3x3 is my sufficient estimate. So you can see this is my right answer. Now this question is only for the sufficient, but if is it a complete? You can see theta is my greater than 0. Fine. So definitely we can obtain the open interval like 3, 4, which is the part of this. So yes, this is the complete as well. Fine. But in this case, they are not talking about the complete. So this is sufficient, always written in the form of hx. Hx is, remember, the coefficient of theta. Look at this another one. Your target is to find the UMVU of theta. Again, you can see what is my hx? Hx is mod x. So what is my t? That is the summation of mod x. Fine. So this is my sufficient estimator of theta. Now how you can prove the complete? So you can see a range is given to you. So theta is greater than 0. So therefore this is also be the complete. Moreover, remember also one more tips that come directly in my mind. So what I prove that this is the sufficient estimator of theta. Now you can see about that. This is how many parameters? Only one parameter. How many parameters here? Only one parameter. So if there are the same number of the parameters, then it is a complete, definitely. However, if you have say T1 and T2 are the sufficient estimator of theta. Now you can see there is only one parameter, but here there are the two parameters. Then it will not be complete. So you can also check the complete by using this property. Now here you can see there is only one parameter. Summation of xi is a 1, that is a t. This also 1, so yes, it's a complete as well. Now then which one of the following is true? Now clearly say what is the distribution of the x. So clearly say mod of x will follows my, because it's exponential distribution, double exponential distribution. So if you open them mode, it will be my gamma distribution. No, it will be my exponential distribution. It is my exponential distribution with the parameter theta. So what will happen if you add them? Summation of them will follows my gamma distribution with the parameter of this. Fine. Now we need a theta. If I use what is the expected value of the t. So what is the expected value of the gamma? Remember, if this is my a comma b, what is the expected value of the gamma? It's a over b. So this is my n over theta. But we need a theta. It is a 1 over theta. So it means there is need to compute the reverse. So what is the my 1 over t? If gamma follows n comma theta, then it will be my theta of n minus 1. That is the inverse gamma distribution. So then what is the meaning of that? What is the expected value of this? It will be again a over b. So it's a over b. So now I need a value of theta. So what is the value of the theta is there? N minus 1 over t is my theta. So this is my right answer. You can check about the option. This option is cancelled because capital T is my here. This should be in the denominator. This is the denominator, but in the numerator we need a n minus 1. And this is my n minus 1 is the right answer. You can see a maximum of 3 or 4 lines you are needed on your copy. Now again you can see it's exponential distribution. Again you have talking about this. So what is that? What is my hx? Hx is my x. So what is the sufficient estimator? Summation of the x is my sufficient estimator of theta. Now again you can see there is only one parameter and this is also one parameter. So we can say this is my complete as well. Moreover, you can see there is some range is given to you, that is from 0 to infinity. So which is the open interval. So you can say yes, it's a complete as well. If it is given like here, then it is my 0 comma infinity. So definitely we can construct the some neighborhood, or you can say some open interval like 1 comma 2, which is the part of this. So yes, this is the complete as well. Now we need a 1 over theta. So what is that? This is my, if x follows my exponential distribution with the parameter theta, what is the summation of the x? It follows the gamma distribution with the parameter here. This is my capital T. So what is the expected value of the t? Expected value of this is n over theta, and we need 1 over theta as well. So what is that? N I can take on this left hand side. This is 1 over. So this is my right answer. So t over n. What is the t is? This over this is my right answer. So this is nothing but my mean. Fine. This is over. Summation n is missing. So this is my over. So the mean is my right answer of this problem. Okay, look at this another one. What is that? It's my discrete problem. Fine. So how you can identify this? Which of the following is my complete? Okay, so firstly we can identify for the x. What is the probability? How many x are there? 0, 1 and 2. 0, 1 and 2. Probability is my 2p. It's a 2p, 1 minus 4p. Now clearly say this is it exponential nature? It is not exponential form. Fine. As I define here, if I exponential form, I can define as a h. Okay, in this form also I can define as a h. But in this example it is not the exponential form. Then how you can check about this? So for that I start from this expected value of the g of t, it should be 0. And my target is to check whether g of t is a 0 for all theta or not. Fine. So I can substitute this value. This is g of t into p of x. So if it is in the form of the x, I can written as a g of x. So x varies from 0, 1, 2. So that means g of 0 into 2p plus g of 1 into 2p plus g of 2 1 minus 4p, which is a 0. Now clearly say I can equate the coefficient of the p on the both side. So 2 times gp, 2 times g1, 4 times g2 is my 0. Fine, this is my coefficient of p, and I can make them as a constant term. This is my only g2 is my 0. So if g2 is my 0, from this we can say g1 plus g0 plus g1 is my 0. So can you say this implies g0 and g1 is my 0? No, we can't say that. So it means this number is not always 0, so therefore this is my not complete. Fine. So x is not complete, x is not complete. Now I can do the same thing for the y. So what is the distribution of the y? How many values are 0, 1 and 2 again? And the probability is my p over 2, 4p square, 1 minus p over 2 minus 4p square. So I can start with a g of this. So g of 0 into p over 2, g of 1, 4p square, g of 2 into 1 minus p over 2 minus 4p square of 0. So I can equate the coefficient of p square. So this is 4 times g1 minus 4 times g2 is 0. Coefficient of the p, g0 by 2, this is minus g2 by 2 is a 0. And I can make them as a constant term. Constant term is only g2 is my 0. So from here we can say g2 is my 0. From here I can say g of 0 is my 0. From here I can say g1 is my 0. So all these three values are 0. Yes, y is my complete. So both x and y are not complete, wrong. Y is complete is my correct answer. Always remember, whenever you have the exponential form, then you can solve it other way, otherwise this manner. Okay, x is my normal distribution. So it is 1 over root pi, sigma is my 1, exponential half x minus theta square. So clearly say it's exponential family. If you open this bracket, what will happen? It is my half x square plus this minus 2 theta x. Fine. So if you open this bracket, it will be my of this nature, but rest of them we don't focus. So what is my hx? Hx is my x. So what is my t is? This is my sufficient estimator of theta. Clear? Also theta is given in the form of the open interval. So yes, this is complete as well. But now we are talking about the sufficient. So that means summation from 1 to n is my sufficient estimator. So yes, this is correct option. You can see it's x1. It is from 2 to n. That means it's a x1, x2 plus x3. So again, you can see yes, this is a sufficient. x1, x2 plus x3 is again a summation. It's also the summations. Yes, it is also the, because all are my independent. x1, x2, x3, 4 to n of summation xi. Yes, this is also with the sufficient estimator of theta. Okay, look at this another one. X follows my Poisson distribution with the parameter this, and capital T is given to be here. Which distribution it follows? If x follows the Poisson distribution, summation of them is also follows the Poisson distribution. Fine. Then you have to find this. Okay. So remember always, whenever you have a Poisson distribution of this, so what is the sufficient estimator of the Poisson distribution? The sufficient estimator of the Poisson distribution is sum of xi is, or x bar is my sufficient estimator of theta. So which is the same of this. So this implies T is my sufficient estimator of theta. Now you can see the dimension of this is 1. T is my summation of xi is also 1. So yes, this is also my complete. Moreover, you can also see that there is an open interval given. So that means this is also the complete. So T is sufficient, T is complete. Now your target is to find this one. So I can give you the firstly tips, fine, and then I can solve you. Okay, firstly I can solve you and then I will give you the shortcut to explain. So look at the first last option. What is my t square over n square? My target is to prove this is theta. So 1 over n square is outside. How you can find the expected value of t square? I can use the variance formula. Fine. So what is that? Variance of t. What is the t follows my Poisson distribution of n comma theta. So what is the variance of this? Is the same plus it is the n square theta square. Clearly say this is not theta. So this option is cancelled out. Now I can look about the other options. So I can start from this numerator side. It's a t square minus t. Fine. So if I open this bracket, it's a e of t square minus e of t. So what is the e of t square? This is the value of the e of t square. So this plus here minus what is the expected value of the t is n theta. So how you can make them as a theta square? If I divide it by n square, then it will be only theta square. So that means this is my right answer of this problem. Fine. Now what is the shortcut twist? Instead of solving this, what is my shortcut twist for you? If t follows my Poisson distribution with the parameter n comma theta, for example like here, then the sufficient estimator, then the UMVUE of this is t minus 1 over n square. However, if t follows my binomial distribution with the parameter say n comma theta, then the sufficient, then UMVU estimate of theta square is t into t minus 1 n into n minus 1. Fine. You can remember this shortcut tricks. So if you remember this shortcut tricks, you can directly get the answer as A is the right answer. Otherwise, you can find the expected value of this. If it is comes to the theta square, then you can check which of the option is the correct one. Okay, look at this another one. x1, x2, x3, x4, x5, x6. So n is my 6 is given to you, and it follows my xi's follows my, it's a binomial distribution 1 comma, when n is equal to 1, what is the meaning of that? It's basically a Bernoulli distribution. Fine. So they have written u in terms of 1 as a confusion. Then theta is my here. Then what is my summation of xi? It follows my, yes, it follows my binomial distribution with the parameter n. N is my 6 and of theta. Fine. Now what is the shortcut tips for you? Your target is to find the UMB of, if I open this bracket here. Fine. So what is that shortcut tricks for you? So capital T, which is summation of xi, if it is follows my binomial distribution of n comma theta, then UMVUE of theta is t over n. UMVUE of theta square is t minus 1 over n minus 1, and similarly for the cube you can write as a 3 times p. Now I can substitute here. What is the value of theta? T over n. What is the value of the t minus 1? N minus 1. N is my 6. What is the t is? Sum of the xi. So can you find the sum of the xi's? So it will be 1, 2 and 3. So what is the answer? 3 over 6 is a 3 minus 1 2, n is 6 into 5. So 1 over 2 plus 1 over 5. So you can see 7 over 10.7 is my right answer of this problem. So this is the simple shortcut tricks you can easily remember. Okay, look at this another one. Xi's are follows my here. So firstly you can write in the PDF 1 over 2 pi into sigma. Sigma is my here exponential half x minus 0 square over variance. Fine. So I need only as a exponential part, so it's a 1 over 4 theta square into x square. Fine. Now can you find the value of the hx? Coefficient of that theta, that is a x square over 4. Or you can simply take, because 4 is my constant, so simply taken as a x square. So what is my sufficient estimator? Summation of x square is my sufficient estimator of theta. Fine. So then is a sufficient estimator. Fine. Is it a complete? So you can see a range is given to you, so that means this is complete as well. Fine. Moreover, you can also see that there is only the one parameter, there is also the one parameter, so yes, it's a complete steady state. Now this is the UMB of this theta square. So how you can find? I can find the expected value of this. 1 over 2n is outside, summation of xi square. Summation is again outside, it will be expected value of xi square. How you can find the expected value of xi square? I can use as a variance. Fine. So what is the variance of this is 2 theta square plus e of x whole square. So what is the right answer of this? It's a 2n theta square over 2n. So theta square, yes. So this is also the correct answer. Now look at this another one, the first and second. So now clearly say, because it's a normal distribution, so once you have the normal distribution, then x1, x2, because they are the IID, they are my sufficient estimator of theta. Each of the xi, because this is also formed from xi square. Okay, so these are the sufficient estimator. Yes, they are the sufficient estimator. Now how you can prove it's a complete or not? What is the dimension of this? There is only one dimension. So remember, this is a comma. Okay? This is comma, it's not a plus minus are there. So how many estimator? It's a t1, this is t2, this is tn. So what is the dimension of this? It is my n dimension, but it is my one dimension. So that means it is my not complete. Always remember, it must be the same, then only it's a complete. So it is not complete. So the A, B, C, D are my correct answers. Okay, which of the following is the sufficient but not complete? So look at that. This is the function. So hx is my x. So it means summation of x is my sufficient estimator of theta. Fine. Now which of the following is my complete? So summation of xi means x bar is my sufficient estimator of theta. Clear? So x bar is my sufficient estimator. Fine. Is it the sufficient estimator? Okay. Look at that. If I say t is my sufficient estimator of theta and f is my 1 function. Fine. Then f of t is also sufficient estimator of theta. Now I prove that x bar is my sufficient estimator. So if I consider the function is my x square plus 3, fine, where theta is my greater than 0. So is it a 1 Yes, it's a 1 function, because if it is a, whenever x is my positive, then it's a 1 but if x belongs to the complete real line, then it is not a 1 So you can see the graph of this will be my parabola. It will be like here only for the first side. So clearly say it is my 1 So once this is my 1 it means this is also sufficient estimator. So yes, this is also the sufficient estimator. Now summation of the xi's is my sufficient estimator. So you can see this is my x1 and this summation is start from the 2 to n. So clearly say this is a complete xi. So yes, this is sufficient as well. This is the x1, x bar. So how you can write the x bar? I can return the x bar in terms of summation xi over n. Fine. Or this number I can return as x1, and in terms of the, I can separate the x1 here, that will be my x1, or I can break x1 over x1 plus summation of the xn as separate. But our target is to check whether it's a complete or not. You can see that. What is the shortcut fix? As I told you, the dimension should be same. If you look about this example, what is the dimension of this? It is my 2 dimension, but we need a sufficient estimator for the theta only. So right hand side is, what is the dimension of this? Dimension is 1, but this is the dimension 2, so it is not complete. Again, it's a comma, fine. So it is a comma, it means it is a sufficient, fine. Is it a complete? It's not complete because the dimension is my 2, but the theta has a dimension 1. The dimension is my 1, theta also has a dimension 1, so yes, it's a complete, but we need a not complete. What is the dimension of this? It's a 1, so it is not a complete. C and D are my right answers. Okay, look at this one. Xi's are my here, y is my given to be this. Can you identify the distribution? This is my gamma distribution with the parameter 2 and theta, fine. Then again you can see it's a function of this. So what is my hx? Hx is my x, so that means capital T summation of the x is my sufficient estimator of theta. So this is my sufficient estimator. Is it complete? You can say also, because this is only the one parameter, this is also a one parameter. Yes, this is my complete as well. Moreover, theta is my greater than 0, so this is an open interval, so yes, this is my complete as well. So I can say this is my y, because in this question is a y is given. So y is my sufficient and complete of theta. So y is my sufficient and complete is my correct option. Now can you find the distribution of the y? X follows my gamma distribution. Then what is my summation of this? Summation of this also follows the gamma distribution with the parameter 2n into theta. Now I need a 1 over y in each of the options. So what is my 1 over y? 1 over y will follows the gamma distribution again with the first parameter is my here, and it will be my 2n minus 1. Remember always, if x follows my gamma distribution with the parameter a comma b, 1 over x again follows the gamma distribution with the parameter b, a minus 1, and expected value of the gamma distribution is a over b. Now I got as a 1 over y, then I find 1 over expected value of this, it is a over 2n minus 1. So I need a theta in the numerator, so this is theta, so it's a 2n minus 1. So I can return this is expected value of 2n minus 1 over y is my, so this is my right answer. So 2n minus 1 over y is the, so this is a 2n cross 2n plus 1 is the cross is the right answer. So A and C are my correct. You can see how many seconds you are needed to solve the problem. 10 to 15 seconds you are needed to solve the each problem, and that much second you are needed to comment and like on the video as well. Okay, look at this one. Which of the following? Firstly, you can see that there is only one unknown parameter theta. You can see that dimension is my 2, fine. So dimension is 2, which is is it a complete? Is it a complete? Not complete, because it's a comma and it's a 2, so it's a complete cross. Not complete, maybe it's a complete cross. Now sufficient, not complete. Now we have to check whether it's a sufficient or not. Can you identify the distribution of this? I can return this is my x over theta is outside and it's a plus 1, so it is my e. So what is that? Basically this follows my exponential parameter, fine. So once we know it's an exponential parameter, what is the once we know it's exponential parameter, so what is the sufficient estimator of the exponential parameter? So we all know. Okay, firstly I will give you the tips. If x follows my exponential distribution with the parameter lambda, then you can say xn is the sufficient estimator of lambda, fine. But here you can see it's a 1 over this, so we can see 1 is the sufficient estimator of 1 over lambda. Fine. So remember this. Now it's a 1 over this, so I can say x1 is my sufficient estimator of 1 over theta. Fine. Now you can see x1 is the sufficient estimator, correct? Fine. So if x1 is the sufficient estimate and x bar is a sample of the size 2, so I can see if you define the likelihood of this, it will be 1 over theta square e raised to power minus 1 over x1 plus x2. So clearly say I can multiply 2 and divide it by 2. So this is my hx, x1 plus x2 over 2. Fine. Or there is no need of things. You can think about from here. What is my hx? Hx is my x. So what is my capital T? This is summation of the x. And what is the sample size is? Only 2 sample. So that means this is my x1 plus x2 is my sufficient estimator. And what is the x bar? X bar is a constant value, so it's a sufficient estimator. So yes, this is a sufficient. Is it a complete? No, it's not a complete, because the dimension is my 2 and theta has a dimension 1. So the right answer is B is my correct option. Okay, look at this another one. Xi's are my random sample, which is my uniform distribution. R is the minimum, S is the minimum, is a joint sufficient MLE. Okay, how you can find it? Firstly, I can find the complete and the sufficient. Look at that. F is my 1 over 2 theta. From here, I can say this is my less than or equal to theta. Fine. Now remember, how you can maximize this? Only when you minimize the theta. Fine. So from here, you can see this is my greater than of this. It means theta should be mod of x comma infinity. But remember that because this parameter, this function is independent of the x, so we will work on the order statistics as I explained you in my MLE lecture. You can see about this lecture MLE. So now what is that? So x1 comma x, because it's a modular sign, so I can return here comma up to xn, I can return in the ordered form. This should be less than of theta. So from here we can see this should be greater than of mod of xn. So that means this is my comma infinity. Now theta should be the minimum, so this is my minimum value. Fine. And this is itself be my MLE. So what is that? Mod of xn is my MLE. So S, is it the S? No. Why? Because mod of xn is my MLE. Fine, but it is not a mod, so S is not the MLE. Maximum of this is my complete. Why complete? Because it is given in the open interval. Fine, and we can get as mod of xi is a complete statistics. R comma S. Okay, so it is my uniform distribution. What I gave you in the earlier tips, in the first question, what is given to you? X1 is my, what is that? Is my sufficient estimator of A. Xn is the sufficient estimator of B. So what is that? X1, that's a minimum R, and this is my S. So R and S are my sufficient. They are not talking about the complete, they are only for the sufficient. Now whether this is independent of parameter, what does it mean? It does not depends. So if the function, if I say f is my PDF, this does not depend upon the theta. That means expected value of this random variable also does not depend upon the theta. So I can find the expected value of this. Fine. Now clearly say R is my minimum, S is my maximum, so they are x1 and xn over x1, they are my independent. Fine. So once they are independent, which theorem you can apply? So by using the Poisson theorem, we can see x of 1 into x of this, or x1 I can written here is xn divided by x1. So if they are independent, I can written as a product of them. Fine. Now that's over. What is the distribution of the x1? If x follows the uniform distribution, this is my beta distribution of 1 comma n. Xn is my beta distribution of n comma 1. So clearly says this, what is the expected value of this is n over n plus 1. This is 1 over n plus 1. So clearly say they are independent of theta. So yes, this is my right answer as well. Okay, look at this another one. Xi's are follows from here. Okay, is it a gamma distribution? X3 e raised to power minus, no, it's not a gamma distribution, because for the gamma distribution we need this as a x. So very simple, if I simply take x cube is my y, then it's my derivative. So it means 1 over theta minus y over theta. It means y follows exponential distribution of 1 over theta. Y is x cube. X cube follows my here. Fine. Now they are talking about the uniform variance. So firstly, what is the hx? Hx is my x cube. So it means summation of the x cube is my sufficient estimator of theta. Now it is open interval, so it means this is complete as well. Fine. So what you can say is summation of the x cube is sufficient plus complete of theta. Also you can see there is a one parameter, this is also a one parameter. So is any option is correct? Now your target is to find the 1 over theta. So your, what is x cube? Can you identify the distribution of the x cube? How you can identify the distribution of the x cube? X cube follows my exponential distribution. Fine. Then summation of the x cube will follows my gamma distribution with the parameter n comma 1 over theta. Now if this is my t. Fine. So if I found the expected value of the t, it is a n over 1 over theta. So it is a n into theta, but we need a 1 over theta. So what I can do, I can take the reciprocal. Fine. So 1 over t will follows gamma distribution of 1 over this into n minus 1. So what is the expected value of this? It's a 1 over this over n minus 1. So I need a 1 over theta, n minus 1 I can written here. So n minus 1 over t is the UMVUE. N over t is this, is a wrong option. N minus 1 is a summation of 1 by t, but we need a t only in the denominator. So this is wrong option. N over t is the MLE. How you can prove the MLE of 1 over theta? So I think that's again a simple. I can start from here. How you can check about the MLE? Okay, remember, if I prove A is the MLE of theta, no, then that you can't say about that. How you can prove that n over t is the MLE? So I can define the MLE. So function which is totally dependent on the theta is my here e raised to power x cube over. So I can define the L. This is my here, it's summation x cube over theta. So now I can take the logarithm. It is minus n log minus x cube over theta. Now take the derivative to be a 0. It is minus n over t. This value is my t. So plus t over cube is my 0. Fine. So what is the meaning of that? N over theta is t upon theta square. So 1 theta will be cancelled out. So I can see n over t is the MLE of 1 over theta. So that's a right answer. So A and D are my correct options. Okay, x follows my exponential distribution with the parameter 1 over theta. That's very simple. I think there is no need to think about that, because this is the exponential distribution, and exponential distribution I already gave that the sum is sufficient estimator of theta. Fine. Now summation of xi is my sufficient estimator. of theta, there is only one and one parameter, so this is also my complete. Moreover, there is an open interval, so that's a complete. So that means x bar is my sufficient plus complete. Now how you can prove this? So I can check what is the x bar. So can you find the distribution of the x bar? Is a normal distribution with the mean. We all know x bar will always follow the normal distribution variance of this. So what is the mean of this? Theta. What is the variance of this? Theta square. So it's a theta square over n. So can you find the expected value of the x bar, which is theta? So yes, this is my UMVUE. Can you find the E of x bar square? Sorry, which is not true. So this is my true statement. X bar square. How you find the x bar square? I can find the variance plus expected value whole square. So variance is theta square over n, and this is my theta square. So clearly say which is not equal to theta square. So x bar square is this is my wrong statement. Now you can see if I multiply this n over n plus 1, then it is a yes. And how you can think about this? Okay, this is by the definition, because we know xn, because summation of the xi's are my sufficient estimator. So this by Rao-Blackman inequality, or the variance, this must be less than of the variance of the xn. So yes, this is my correct statement. So these A, C, D are my correct statement, but we need a not correct statement. B is my right answer. Okay, look at this another one. Xi's follows my Poisson distribution, then sum of them. So we all know that for the Poisson distribution, this is my sufficient estimator. Moreover, this is also written in the open interval, so this is sufficient as well as complete. So that means capital T will follows again the Poisson distribution with the parameter n comma theta. Then your target is to find the uniform minimum variance estimator of this. Okay, so if I consider this is my y is e raised to power minus 2 theta of this. So clearly say if I compare this, because it's a Poisson distribution, what is the PDF? E raised to power minus n theta raised to power x over x factorial. So clearly say n is my 2. So I can write this y in terms of this. Fine. 2 theta is a cube. So I can take x as my cube divided by 3 factorial. So I have multiplied by 8 and this is my 6. Fine. Now it is with my here. So what does it means? This y is nothing but 6 over t into Poisson distribution of the 2. Fine. This is my capital T, or where capital T here is Poisson distribution of 2 theta. Then your target is to find the this one. That's very simple. Okay. Now how you can think about this? So firstly I can write so your target is, now since in this case you can see in the previous examples you have a given of this only the theta, but here the value is given in terms of the joint function. So your target is to find expected value of this y. Condition, what is the sufficient estimator? Capital T. Fine. This is equal to this value. Fine. But I will tell you the simple shortcut tricks. Look at that. What is that? This follows my Poisson distribution. What is the distribution of the y? If t follows the Poisson distribution, y is also follows the Poisson distribution. Fine. Now what is the shortcut tips? If you remember, if x follows my Poisson distribution with the parameter lambda, y follows my Poisson distribution, if I call this is my x, lambda of y, then x condition y will follows the Poisson distribution of y, whatever the value of the y, and x over y. Sorry, it's a binomial. Fine. So it means I can found the distribution. This follows my binomial distribution. What is the value of the y? Can you find the value of y? It is not given. I can written as a here. This is my or instead of y I can call as a t. And what is the mean of the y? So can you find the mean of y is a 2 theta, and what is the mean of the t is n theta. So it is my 2 over theta. So now let me clear this screen so that you can get your answers right now. So it means y over t will follows my binomial distribution with the parameter t comma 2 over n. Now that's over. Fine. So this is my capital T, because because my target is to capital T. So this is my capital T. What is the value of the y? What is the value of the n is my 2. Fine. So now you can see what is the right answer of this. 6 over 8 into probability of what is the n is 3. You can see theta cube, n is my, this is 3. So I can say this is my 3. Fine. So 3 is a binomial distribution, 3 comma here. So now what is the binomial distribution of this? So instead of this I can simply say it's a t. Fine. At the point 3, so it's a tc3 2 over n raised to power 3 1 minus 2 over n t minus is the right answer. So clearly say this is not in the exponential form. There is an existence, so this option is also cancelled. Now you can see it's a power. How you can see open that? Now you can see 2 raised to power 8. This will be cancelled out. Okay. Now tc3. How you can open this tc3? It is my t minus 1 t over 3 2 1 6. It's a 8 over n cube. It is n minus 2 over n here. So 8 will be cancelled, 6 will be cancelled. So t minus 1, t minus 2, n minus 2 raised to power here. Yes, this is my right answer of this problem. Okay, look at this another one. x1 and x2 are there. N is given as a 2. Again is a Poisson distribution. Fine. So what is the sufficient estimate of the Poisson distribution? Sum of xi is my sufficient, and again you can see the interval is given in the form of the open interval, so it's a complete. So therefore t summation of xi is my sufficient and the complete. So what is the distribution of the t? If again it follows my Poisson distribution with the parameter, because there are the 2, so it's a 2 comma theta. Fine. Now xi cap is the uniform of this. That means this should be equal to this value. K is equal to 4 of, okay, what is that? This is again the Poisson distribution with the parameter theta. Fine. And it's a summation of this. So I can return this value. This only right hand side is nothing but, if I call this as a k, k is equal to 4. Fine. Sorry, greater than equal to 4, because it's a summation sign. So my target is to make them as probability of x, or called as a x. Oh, so x is already given, I call as a y. So probability of y is greater than equal to 4. Fine. Now a very simple approach is given to you. Again, your target is to identify y is already given h condition t, where t is my here. Fine. So what is the h? H is my index. So index is given as a here. So that means expected value means you can write as a probability of y greater than equal to 4. I can return also this is 1 whenever probability y is greater than equal to 4, otherwise 0. So I can, how you can find the expected value? 1 into this divided by condition of this is summation of xi is my here. Fine. Now how you can find the probability of y is greater than. So y is nothing but my xi's. So that means x is my, I can change them to be x is 4 because it's a xi's. What is the sum of the xi's? Sum of the xi is my 5. So that's over. So my target is to find this. X1 plus x2 should be 5. Fine. So what are, this x is my combination of the xi's. So what are those possibilities? Intersection. Either x1 will be 4, x2 will be my 1, or x1 will be my 5, x2 will be 0, divided by x1 plus x2 means probability of t is equal to 5. Now they are my random sample, means independent. So what is the probability of this? What is the probability of x1 is equal to 4? x1 will follows my Poisson distribution. So e raised to power minus theta, theta raised to power 4 over 4 factorial into e raised to power minus theta, theta raised to power 1 here. E raised to power this, theta raised to power 5 over 5 factorial, e raised to power minus theta raised to power 0 over 0 factorial, divided by capital T. Capital T follows my Poisson distribution of this. And what is the value of this is e raised to power minus lambda, lambda raised to power 5 over 5 factorial. So clearly say e raised to power minus 2 will be cancelled out. Theta raised to power 5, theta raised to power 5 is also cancelled out. So the numerator part in this case is a 1 over 4 factorial. It's a 1 over 5 factorial divided by 32 over 5 factorial. So if I multiply by 5 factorial, it will be my 5 plus 1 over 32. 6 over 32 means 3 over 16 is the right answer of this problem. So this is the way you can solve this here. So remember, up to the so far we have given whatever you want to find the unbiased estimator. You can see in each of the case it is given that. But in this example, it is given not in the form of theta but in the form of the functions. So we have to apply these conditions. Again, this is not given in the form of the proper theta, it is given is here. Okay, look at this another one, which is 2023 nxi. So n is my 3, follows my this. Can you identify which distribution is here? Is a, okay, this is a geometric distribution. Fine. And what is my summation of xi's? This is my sufficient estimator. Is it a complete? Yes, we can see it's an open interval. Fine. So yes, it's a complete as well. Fine. So if I call t is my summation of xi, do you know what is the summation of the geometric distribution? It follows my negative binomial with the parameter n. N is my 3 and here. Fine. Then tau cap is the uniform estimator of theta square. It means of this. Fine. So then what is the value of the tau square? From here, can you think about how you can make as a theta square out of these three here? Clearly say if I take x is my 0, if I take x is my 0, like here, x1 is my 0, x2 is my 0, or x1 is my 0, x3 is my 0, or x2 is my 0, or x3 is my 0. So what is that? Because they are my observed random sample, they are IID. So what is the probability of x1 is equal to 0? Theta into theta is a theta square. This is theta square, this is theta square. So you can use any one of them. Fine. You can use any one of them. So let's say I can use my here. Again, it is not exactly given to you. So what I can choose? I can choose expected value of the y condition theta. Fine. This is tau is my here. So I can return again. I can choose this value is my 1 if x1 is my 0, x2 is my here, otherwise 0. So what is that? This is expected means probability of x1 is 0, x2 is 0, condition summation of xi. So what is the sum of the xi? Can you find it? 9 and 11. So this means probability of x1 is 0, x2 is 0, condition sum of xi is my 11. So what is that? So it means if I take this is my capital T is my 11. It is if x1 is 0, x2 is 0 and summation is 11 and n is my 3. So definitely x3 will be my 11. Fine. So can you find the numerator value? Probability of x1 0 is theta. Probability of x2 is theta. Probability of x3 is my 11. So this 1 minus this of 11. And how you can find this? What is the PDF of t? Because it's a negative binomial, so it will be my 3 plus x c this theta cube 1 minus of of x. This is my x. Fine. So I can substitute here is 11. So it's a 14 c3 theta is power cube 1 minus theta of 11. So you can see this value will be cancelled out. So the answer will be 1 over 14 c3. So now I can solve it. So what is that? I can write here 1 over 14 c3, 14, 13, 12, 3, 2, 1. So 3 2 just 6. So 1 over 14 into 13 into 6 multiply by 156. So can you get the answer? So 6 2 is 12, 36 is my 2. Then it will be my 1 over 7. Is it true? You can check it. Oh sorry, it's a geometric, it's a negative binomial, so it will be my 2 n minus 1. Okay, it's my 2. Fine, rest is fine. Or just wait. So this will be my this and it will be 11 and it will be my 2 is 11 13 c3 cube 1 minus of 11. So rest or cancel. So it will be 156 into 1 over 13 12 11 over 3 6 2 1 is a 6. Now you can see it's my 2. It 2 will be my 7 2 is 14 76 78. Then is it a cancel out? It is not cancel out. So where is my mistake? Oops, sorry, again this is my 2 cx and 2, so it is my 2. Oh, it's just a calculation are there, you can do it by calculation on anyhow. 156 1 over 13 into 12 and 2 into 1 is upside, so this is 6 will be 2 26. So 13 into 2 is the right answer of this problem. Fine. So remember, always it's a very simple approach. You must remember that what is the distribution of the problem. This is the PDF of the negative binomial distribution. Remember that it's a whatever the n, it is a n minus 1. So that is my error. That's why it takes some time to solve this problem. So I hope you can simply learn the many tricks in this lecture. We will see the next lecture on the UMV plus Cramer-Rao inequality related problems from these examinations. Till then, I hope you can like, share and comment on my video. Best of luck students. Happy learning.